Toxin, substances that make us watch our step and examine our surroundings carefully. Whether it's venom or poison, the creatures that produce these dangerous substances both terrify and intrigue us. Even seemingly harmless animals or plants can cause harm ranging from mild discomfort to death. Although the terms venomous and poisonous are often used interchangeably, they are two distinct forms of toxins created by living things that can cause harm to other living things. So, let's have a look into this. You are watching Lecture It. A toxin actively injected through a bite or sting by an organism makes it venomous, whereas absorption of the toxin by ingesting, breathing, or skin contact makes it poisonous. Some animals produce substances that are both venom and poison. For example, when a spitting cobra sprays venom into your eyes, it gets absorbed into your body through your skin, making it a poison. However, if the cobra bites you, injecting the same venom, it becomes a venom. Except for spitting cobras, poisons are generally passive, requiring the critter to wait until they are touched or bitten. Poison is typically used to defend against predators, whereas venom is active and can be used to ward off predators and hunt prey. In this discussion, we will be exploring some of the species belonging to reptiles and amphibians, a group well known for its venomous and poisonous members. Toxic reptiles often carry more than enough of their deathly substance because of an evolutionary arms race. For instance, the cane toad produces bufotoxin in a gland behind its ear, which interacts with the heart muscles, causing them to beat so hard that they eventually stop. The toxin is lethal to most animals that attempt to eat it, but the false water cobra has developed resistance to it over many generations. As a response, cane toads began producing even more toxin, and the snakes developed even more immunity, resulting in the snakes currently winning the arms race. Unfortunately, cane toads were introduced to Australia from Hawaii in 1935, with sugarcane farmers hoping they would eat scarab beetles destroying their crops. However, the toads became a highly destructive invasive species, killing animals that eat them and those that don't know about their poisonous nature. This introduction caused a massive die-off of many of Australia's native predators, including shingleback skinks or blueies, which are omnivorous and eat almost anything they can fit into their mouths, including cane toads. Unlike the false water cobra, blueies did not evolve alongside cane toads and therefore have not built up immunity to their toxin. But the lizards have an unlikely ally in their arms, race against the toads in the form of a poisonous plant called mother of millions. These plants have evolved a very similar poison to the cane toads. Before the toads' arrival, the blueies were eating mother of millions and getting poisoned. Not all of them died, and the surviving ones went on to breed, producing more poison-resistant skinks. Therefore, where mother of millions grows, the blueies are winning the race because they've had a head start on resistance. However, where there are no plants to help them out, cane toad poisoning has completely wiped out populations of blue-tongue friends. Venomous snakes like the king cobra have to maintain a level of toxicity that can kill their prey, including other venomous snakes. In addition to producing their own neurotoxin, the king cobra must be immune to the venom of the snakes it eats. This two-way arms race with the common krait, which kills up to 80% of humans that it bites, requires the cobra to maintain its own immunity to the krait's potent venom. All of this is quite costly for snakes, as the energy required to produce more venom varies among species and can be extremely high. For example, the Australian death adder puts 1/6 of its energy into producing more venom for 3 days after biting. This is equivalent to the energy pregnant humans put into growing a baby. Many venomous snakes display visual cues that advertise their toxic nature, including warning coloration, rattles, and hoods. These cues communicate that they'd rather not waste their venom on something they can't eat, such as humans. Snakes are not only in an arms race with their prey and one another, but anthropologist research suggests that humans are also in an evolutionary arms race with venomous snakes. According to their work, humans have evolved better color vision and an eye for detail, while snakes have developed more potent venom and better camouflage to avoid detection. Toxic animals terrify some people, but they also provide us with life-saving medications made from molecules that would otherwise be deadly. The best-selling drug of all time is captopril, a heart failure and blood pressure medication made from Brazilian pit viper venom. Yew trees produce a poison that has been on the market as a cancer medication since the 1990s. Aside from any potential benefits that humans may gain from extracting toxins from these animals, they play a vital role in their environment. Thus, it's essential to respect and appreciate not only these toxic animals, but also the species that are co-evolving alongside them, including ourselves.